All right, today we're pulling back the curtain on something truly powerful, something that's really the engine behind so much of our digital world. We're talking about supervised learning. Let's break down exactly how this thing works.
Okay, so let's kick things off with a mystery you probably deal with every single day. How does your email know what's spam and what's actually important? I mean, it feels like magic, right? Well, it's not. It's actually a perfect, real-world example of supervised learning.
Now, to really get how your spam filter does its thing, we've got to zoom out a bit. It all starts in this huge, really exciting field, artificial intelligence. You know, the big, overarching goal of creating machines that can actually think and learn.
And inside that giant world of AI, there's this one specific approach that has just changed everything. We call it machine learning. See, instead of trying to program a computer with a million different rigid rules, we just give it a ton of data and let it figure out the patterns all by itself. It's a total game changer in how we build smart systems.
And that, right there, brings us to our main event. The most common, and honestly the most powerful type of machine learning is what's called supervised learning. This is basically the workhorse of the entire AI world, and it's what we're going to dig into today.
So what's the secret sauce here? What makes supervised learning, well, supervised? It all boils down to something called labeled data. And honestly, the best way to think about it is like giving the machine a study guide, with the answer key in the back. You're not just throwing problems at it, you're giving it the problem and the correct answer, that label right there with it.
Let's bring this right back to our spam filter example. The raw email itself, the text, who sent it, the subject line, all of that is the input. The label? That's just the simple, correct answer we give it, spam or not spam. And the machine gets to see thousands, even millions of examples of both.
So how does a machine actually learn from this answer key? Well, it follows this really simple but super powerful four-step loop. First, it takes a piece of data and makes a guess, a prediction. Then, it compares its guess to the real label to see how wrong it was. Based on that mistake, it adjusts its internal logic just a little bit to try and do better next time. And here's the key. It repeats this process over and over and over millions of times, getting a tiny bit more accurate with every single pass.
And this really gets to the heart of supervised learning. It's the perfect tool for the job when your outcome is crystal clear, when you have a definitive right answer. The rule of thumb is, if you can label it, you can probably teach a machine to recognize it.
Once you get this concept, you start seeing it absolutely everywhere. It's the tech that asks, is this credit card transaction fraudulent? Or, is this a picture of a cat or a dog? It's even used to predict the future, asking things like, what's the price of this stock going to be? Or, how much product demand should we expect next quarter? Okay, so to recap real quick, supervised learning is so powerful because it learns from data that has the answers baked right in. But that, of course, leads to a really interesting question. What happens when you have a ton of data, but no answers? Well, that's when we step into the world of unsupervised learning.
And that leaves us with a final thought, a little cliffhanger for next time. What happens when a machine has no answer key at all? What happens when it's forced to find the patterns all by itself?